So I got the idea of like possibly I've got a couple of 260 watt solar panels that I don't know how hooked up. Putting some 12 volt batteries down here, or even my spare inverter. I've got a pretty large battery actually, but it can't be. It doesn't have a battery heater. It's a lithium iron phosphate battery, so it can't be out here when it freezes because this is a shop. And so basically, the lithium batteries, I think they're fine if it freezes. Just like it will happen is if the solar tries to charge the battery while the battery is anywhere near freezing temperature. It's not even freezing. It's like probably 40 degrees or lower. I've seen where that's the issue. When I worked for the solar company, they were saying that they had batteries that swelled up and did weird stuff at 40 degrees. So it doesn't have to be freezing. So anyway, we've all seen what happened with all the Teslas lately and all that. I don't know what those are using. I don't think they're using lithium iron phosphate, but for solar, that's what you want to use, lithium iron phosphate. You don't want any other stuff. I'm still using these lead acid batteries. But I've kind of found like this really weird deal. I know this looks like a mess, but the batteries, if you take two perfectly matched batteries and you run them at 24 volts, one of them always charges differently than the other. So for some reason, when I put three of them of the same size, but two of them in parallel, they all seem to balance out. I have no idea why. But anyway, these are just like a year or two old batteries, and I'm just using them. So I'm running the heater and some other stuff. I'm on this one right here. Here we go. This isn't the only one that's hooked up, but this has got like a majority of the panels on it. So we look at it, we see, and up is backwards on the menu system here. I'm actually going down. We have a total is produced 1.27 megawatts. The year is 131 kilowatt hours. The month is 66.8 kilowatt hours. The day is 355 watt hours because it's not only just barely been on. We're putting 30 amps into the battery. We're producing 953 watts right now at 55 volts. And our load is 1.57 kilowatts. So that's because the space heater is on high, which draws 1200. We have a bunch of panels on here that are producing 15 amps. This is where you can see the MPPT really work. So we're sending 62 volts in here at 6.7 amps. When it converts that to 24 volts, it gives us an extra like 7 or 8 amps. It does not waste the voltage and current. If it reduces the voltage, it ups the current. And that's the difference between an MPPT and a PWM. The PWM pulses on and off a whole bunch of times, which will wipe out your radio. And it does that to get rid of extra power. So it cuts down that 61 volts to 27, which is around what you want for a 24 volt battery. A 24 volt battery system is not really 24 volts because you're going to be optimally about 12.8 per battery, which means that you're going to be, 12.8 times 2. So puts you in the ballpark of around 27. So anyway, you get that extra boost there without wasting power. So I don't know how many panels are on that one, but So 15 to 20 amps is about, it's probably about 470, 450 watts. And we've got all this craziness down here. Each one of these is a 40 amp MPPT charge controller. And you can't really see them too easy. This one's got the data cord connected to it, and then this one does not. So I actually have about 14 amps coming into that one and 15 going out. So you got about six. So we have 14 and 14, so about 28. So about like, you know, somewhere around 30 amps right there, which is almost 1,000 right there. And then we're putting out 900. So almost 2 kilowatts instantaneous, which is, you know, if you run that for several hours, you get your kilowatt hour, you know. So you could instantaneous, like, some people get confused, the kilowatt hour and the instantaneous. But like, if I have 1.9 kilowatts instantaneous and I run that for, let's just say I have 2 kilowatts instantaneous and I run that for 8 hours, well, then I've got 8 kilowatt hours. But my system can't provide me with 8 kilowatts of power at once. So anyway, I'm running the dryer, laptop, and some other stuff off of here too. I just was like, you know, this dryer's got to be pulling some juice. So I need to get the clamp meter on it, or use the kilowatt device and see what it draws. But if it's a heater, it's heating the filament. These 3D printers, they've all got to be drawing some power. So if I'm going to run these all the time, they're probably going to make my power bill go up a bit. So I'm not printing or anything right now, but what I'm going to do, what I want to do, is I want to get everything organized in here, and I want to run all of these things off of solar, including the radios. I want to have a 12-volt battery bank down here. I've got an extra EP-Ever charge controller up on the shelf. It's 40 amps. And I'll just put the 2 panels on there, which is like totally perfect. In fact, you can't get 40 amps out of 2 panels. You can get 20 under ideal. Like, that's absolutely perfect. Because a panel usually can only put out about 10 amps. Anyway, and we're not talking, you know, your Amazon 100-watt panels. We're talking residential panels. But there's nothing wrong with those either. You know, you don't need a whole lot of panels to charge a 12-volt battery bank. And a radio, as we've seen, you know, they don't draw a lot. Right now, I'm charging the lithium battery, and I'm just using a battery tender. And so that's just simple for me for lithium iron phosphate. I charge my drill batteries and things like that over here too. Just real kind of fly by the seat of your pants kind of setup. But anyway, you know, it works for me. So yeah, I want to put some batteries down here, and then I've got a couple of panels hooked here, so it's no big deal. Main thing, actually, what I want is, I don't want the batteries there. I actually want them outside. I want them on the other side. There's a hole in the wall over there. What I want to do is build an enclosure, take some of my old junk car batteries and let them charge, and put them in a fireproof kind of enclosure, and just let them go. Let them do their thing. So, you know, with any of the battery stuff, there's always a risk that something could happen. So you need to make sure, put circuit breakers and things like that on everything. Anyway, That's just an idea I had. I'm trying to tidy up everything again, and I'm like, okay, well, let's put all the tools away. Let's figure out where everything is. Let's grab up all the drill bits, put them back in the drill bit drawer. It's a mess. And then I was screwing around with this thing. I don't know if it works correctly or not now. I figured out one of my oscilloscope probes is no good. So I was having some problems testing some stuff, and I think that the probe's no good. So I'm like, wow, okay, that's why I couldn't figure out what I was doing. But I don't think this thing works correctly. I think it only works on certain spots of the times per division. So these are plug-in modules. They're super simple. Literally pull it out and troubleshoot it, I guess. B&W Electronics, Melbourne, Australia. So I think there's something wrong with this thing. This is a scope that's designed to have plugins. I probably won't find one again unless Sam is at the next Hamfest. He gets these from different radio sites and things like that, and Fire Stick and whatever. They closed down a site they were working on. But that would be pretty hard to find these. I forget what this is, a Model 525, and I don't remember the company's name. It's not this company, but they're the ones that made it. Anyway, I'm gonna do some straightening up. We'll catch you guys in a bit.